This is video 15 exploring payload serialization in serial transfers on STM32 MicroPython and a desktop Python application. The code for this video is at the GitHub site. The information presented in these videos on MicroPython should work as well on any STM32 F4 board. All code examples have pin definitions at the beginning of the file to allow the programmer to alter as needed. As this channel covers multiple microcontroller solutions over time, please subscribe to stay informed and click like, as that really helps. In this video, we continue to explore serial transfers by looking at methods to serialize the payload. The best payload method for your transfers could influence other decisions. Through internet searches, we located a discussion on serialization and two serial transfer examples. Let's examine the methods. Before we do, let's talk about Endian. Serializing data into bytes involves Endian. The order in which the bytes are stored or transmitted can be big Endian or little Endian. Numerical values are stored as a set of bytes. For example, IBM mainframes store data big Endian. In MicroPython, you can invoke this snippet to learn how your computer stores numbers. As you can see, the computers we are using are little Endian. Despite this, bytes in most transfers are transmitted big Endian. Okay, serialization. Peter Hinch provides us with an excellent article on serialization. He describes 5 methods, but only 4 are practical on microcontrollers. The first 2 represent methods that produce readable formats. He cautions that JSON, although widely used, does not support all Python objects, whereas Pickle supports Python objects but produces longer output. Regardless, he felt it was easier to debug streams of ASCII. The next 2 are binary formats, which can usually be very compact. Struct is widely used in Python programs. However, the exact format must be known by the sender and destination, otherwise the data becomes mangled. By the way, I found that the Boolean type is not currently supported in MicroPython. He then discusses message pack, which is compact and can be easily decoded by the destination. There may be a need for care when going between a microcontroller and a desktop. Okay, so let's look at the code. The first example is with JSON. We'll run the JSON test on the microcontroller in loopback first. So this is an example of a test program using JSON. I put the messages between these comments. That is the actionable part. The rest is just messages so that we can see how it works. So here's how we're going to dump the message and encode it. Here's how we're going to receive it. Let's run it. When we press the button on the keyboard, it sends the message and receives it. So you can see the message I'm sending is hello as a string of bytes, the integer 15, a Boolean true, and a float value 1.414. JSON encoded that into 26 bytes, which it then received and decoded. All right, it works great. Let's run the desktop in loopback. Here we are on the desktop. Let's make sure we're in loopback. And we'll run the program. All right, first we'll press the S key on the keyboard to send the same message. And as you can see, it sent the message hello 15 true and 1.414 and received it and decoded it properly. Okay, that's great. Now let's connect it. Let's connect the 2 systems using our Bluetooth. All right, I'll restart the microcontroller, and I'll go back to our Python program and take it out of loopback. Save it. Oh, I probably should quit and restart it. Very good. We're running in loopback. All right, let's press the button on the microcontroller. Okay, the microcontroller sent the message. It was received by the desktop and parsed correctly. All right, we're on the desktop. We'll press the S key. It sent the message, and it was received by the microcontroller, and which parsed it correctly. So, all right, that's good. JSON works great. Let's try the next method, which is pickle. All right, so we'll stop everything. Stop everything over here. Switch to pickle. Let's switch back to loopback. Okay, we're at loopback. Very good. Let's run the program in loopback on for pickle. Notice before I do that the switch to pickle. Let's notice before I do that the message does not need to be encoded into bytes like JSON. Pickle will dump the message into a byte array. All right, that's nice. And it will easily load it just like JSON. So let's switch back to our loopback wire. We'll run the microcontroller. We'll press a button. Okay, it sent this message, hello, 15 true and 1.414, and it received it just as well. Okay, so that's good. Let's run it on the desktop now. We'll switch to pickle. And we're running it in loopback. Okay, we sent the message. Let me move up just a little bit here so you can see both. So we sent the message, hello, 15 true, 1.414 as before. Notice it's 35 bytes, which is pretty long, but it was able to decode it just as well. All right. Let's send it to the, we send it to the microcontroller. Oh no, let's take it out of loopback and connect the two. All right, so let's quit. Take this out of loopback and save it. This one we'll take off the loopback wire and put it in our Bluetooth module. We'll restart the Thony. And we'll restart our desktop. Okay, you can see that it's connected to the microcontroller. Let's use the microcontroller and send a message to the desktop. It did. It was received by the desktop. That's good. All right, let's go from the desktop back to the microcontroller. Uh-oh. It crashed on the microcontroller. So the microcontroller can send to other microcontrollers. The desktop can send to other desktops. The microcontroller can send to the desktop, but the desktop pickle cannot send to the microcontroller pickle. And that was a warning from Peter Hinch. He suggested that they are incompatible. All right, let's go on to the next method. So we'll stop everything, switch to structure. I already stopped over here. We'll keep this we'll keep the Bluetooth connected now that we see how things are working. The first thing we noticed about structure in our microcontroller code is the need for this schema. So hello is a string of 5 characters. 15 is an integer. Oh wait, for structure, we can't represent Boolean. Well, why is that? Let's go to the website and look at that. When we look at structure at the MicroPython site, we don't see a definition for Boolean. All right, so the only thing we can do is represent true and false is with a 0 and 1. So 1 is true in this case, and so we'll encode it as an int, and we'll put in the 1.414 as a f. With this format, we then need to calculate the size of the message. We need to create a buffer with a byte array of that size, and then we need to pack it with structure. And notice that we need to specify each object. And the 0 is an offset into the message, so we're sending the whole message. All right, up here under the receive, you'll see that the receive function will need to unpack it, but it will also need to know the structure. All right, so let's go to our desktop and start our Python program. We're connected to the Bluetooth, because it's still there, but we need to start the program. Okay, so let's press the button on the microcontroller. Okay, the microcontroller sent the message to the desktop, and the desktop received it. So we got the hello 15, the 1, but look at what it did to our floating point number. It did that thing that numerical values do in floating point, is it approximated the value. All right, let's send it back from the desktop to the microcontroller. We'll press S. You can see it formulated the message, and our microcontroller received it, no issues. So that's good. So structure does work, albeit with this slight difference here, although we could easily truncate that after 3 digits, couldn't we? Notice that the message size is the smallest of all the formats. So we like structure. It's very compact. All right, let's try the last one, which is message pack. So we'll stop the program here. We'll come over here to the microcontroller and stop it. We'll bring up message pack. We'll start it. We'll come over here to the desktop and start message pack. Very good, and it's connected to the Bluetooth. All right, let's use the button on the microcontroller and send to the desktop. Okay, the microcontroller sent the message to the desktop using message pack. Notice that the message size is 17 bytes, just like struct. So we like that. It's very compact, just like struct. And the desktop received it and did the fancy approximation with the floating number, but otherwise it received everything just like the struct format did, and it's also 17 bytes. So message pack is very good, I'll bet, with this slight approximation. Let's send from the desktop back to the microcontroller. Okay, we sent. I pressed it twice, but you get the idea. It sent the message to the microcontroller. The microcontroller received it and parsed it correctly, just like struct. We've got the hello 15, the true, and the 1.414. Notice, though, that the message is slightly larger, so there's only a difference of 1 byte between message pack and struct. So I think that's a good trade-off, considering that message pack is very easy. You just use dumps, just like in JSON, and you just use loads. Okay, on my STM32, I am using this message pack from WZAP, and it's an older copy of the software, maybe 3 years old. But I had trouble using newer versions because on my STM32 MicroPython, it gave me a memory allocation error. But it works fine other than the items that we've talked about already. In summary, what have we learned? We learned that our platform is Little Endian, but some systems transfer Big Endian. We reviewed the 4 common serialization approaches for our transfers between STM32 and Desktop Python, and we found that JSON is easy to use, though the message size is big, but it worked all 4 ways. We found Pickle, and I didn't do very many tests, but Pickle is very Pythonic, and it can encode many different kinds of Python objects. And it has a message size that's similar to JSON, which is large. However, it only worked 3 ways. Struct use a complicated schema that must be known by the sender and destination. But it does provide a compact message, and it worked all 4 ways. However, we did notice that the floating point number received by the desktop used that approximation floating point arithmetic, and we would have to truncate the values there. For the new message pack approach, it's easy to use. So we don't have that complicated schema. It gives a compact message just like struct. And it worked all 4 ways, but it also gave a funny represented value on the desktop. Well, hopefully you understand the trade-offs between the 4 and can choose the best approach for your next project. In the next video, we will continue to look at serial transfer approaches. Thank you.